Okay, you guys still writing those? Okay. So I want to talk about the questions as soon as everybody gets done. All right? Which was, there were 3 blue questions in 1 through 5, which I told you I was going to give you some more time on today, but we'll just kind of do it together. Is that okay? So you can get those in there. You'll still have to get your points for the lab, you'll still have to send me those answers. All right? Even though we're going to do them together. So make sure that you do that sometime. Some of you have already done that. So let me ask you this. You see a trend here? Is mass always being gained or always being lost? It's kind of all over the place, right? We used to do a trial 2 on this. After we explained it, I'm not going to take the time to do it today. I'll just explain it to you. There's a lot of different places for errors. Anybody spill any salt while you're trying to pour it into the container? Right, that's a source of an error. If there's water on the outside of your container, that's a source of an error too. So those are all problems in this experiment, and that's the reason why we sometimes get a loss, we sometimes get a gain of mass. But really, if you think about it, we want to know, does mass change? If all the salt got into the plastic bottle, okay, all the atoms that make up the salt, all the atoms that make up the water, when the salt dissolves, are the number of atoms going to change? No. Okay, so if you did a good job on this and you took your time, and I actually did this on a YouTube video, and I didn't get 0 either, okay, and I tried to be perfect on it, mainly because I'll blame the balance, okay, not being exact, but that's the biggest problem that we have. But if you were to do this perfectly and have really good equipment, what you would find is the change in mass would be 0. And it makes sense that it would be 0, because really all the atoms you start with, you end with. You have a tight seal on the plastic container, so it's not like water's going to evaporate away. So what you should see for a change in mass, even though the volume changes, is that the change in mass is 0. So let's go through and talk about, there are 3 blue questions for you to answer. And I'm gonna, anybody still writing those? Are you all right? Okay. I'm gonna go through and talk about these real quick. So blue question number 1, taking into consideration the sensitivity of the balance, what do you conclude about the mass of salt and water as the salt dissolves? I'm going to say this. It should be 0. I don't really care what you got, what you saw. Just put in there for blue question number 1 that it should be 0. Then number 2, it says, considering the sensitivity of the balance and the results of the entire class, which we just wrote up here. What does your class conclude about the mass of salt and water as the salt dissolves? Same thing. So for number 2, put, it should be 0. And then number 3, can you suggest any reason why all the members of the class do not find the same change in mass? Well, we just gave you some, okay? So I'm just going to say experimental errors, which would be spilling the salt, okay, having water on the outside of the container, not reading the mass carefully. We could even talk about the sensitivity of the balance is a problem too. The actual sensitivity of the balance, which we did a lab over that, I think it was last week when I wasn't here, but the sensitivity of the balance should be about 0.05 grams. So if you're within 0.05 grams, you've done a pretty good job. You're off by the sensitivity of the balance. So let's go through and answer questions 1 through 5 also. Number 1, says here the results of several mass measurements in which is the change stated correctly. So if the mass before is 42.67 and the mass after is 42.65, is that correct? No, it shouldn't be plus 0.02, it should be what? It should be minus 0.02. It lost 0.02. So A is not correct. What about B? Is 69.05 before and 65.05 after give you a change in mass of 0? No. What about C? Is 43.12 before and 43.22 after? Is that a gain of 0.10? Yeah, so that's correct. So you can put, I'm going to circle it, but you can just put number 1. One of the answers is C. Let's check the rest of them. Is 43.10 before and 42.95 after a change of negative 1.15? No, it's just negative 0.15. So that one doesn't work. And what about E? Is 25.64 before and 25.61 after a change of negative 0.03? Yeah. So E should be written as well. So the answer number 1 is C and E. Number 2, you need to know the individual masses of the samples of water and salt in order to measure the change in mass when the two samples are mixed. So I'm going to put number 2 right over here. No, you don't. You could do it that way if you wanted to. You could find all the masses of everything before, but to compare it at the end, you've just got to add them all together. So we're saving some steps by not making you add it all together. Okay, so you don't have to do the individual stuff. And as you'll see in this chapter, we're going to do 3 more experiments like this, and we're always going to do total mass before and total mass after. Okay, this is going to give you more chances of errors too if you do the individual masses. Number 3, in experiment 2.1, how could you recover the dissolved salt? Any ideas on how to do that? How do you get the salt back?
Evaporation.
Right, you can evaporate the water. So I'm going to say for the first part, evaporate the water, comma. Then it says, how do you think this mass would compare with the mass of dry salt you started with? It's going to be exactly the same. Okay, if we did a good job of keeping it. Number 4, if the change in mass in experiment 2.1, the mass of dissolved salt, were negative 0.0001, so what, negative 1/10,000th of a gram, would you have observed this change using your balance? Well, we can only estimate to the hundredths place, so for number 4, that's going to be no. And then number 5, it says in daily language, we express the sign plus or minus of a change by using different words. For example, Elizabeth gained 1 kilogram, Tom lost 2 kilograms. Express these statements in terms of change in mass. So gaining 1 kilogram would be plus 1 kilogram. Losing 2 kilograms would be minus 2 kilograms. And then on B, it says in the morning the temperature rose from 10 to 14. In the afternoon the temperature fell from 16 to 11. What were the changes in temperature in the morning and the afternoon? So if it went from 10 to 14, that's plus 4 degrees Celsius. And if it went from 16 to 11, that's minus how much? Anybody? Minus 5 degrees Celsius. Okay, so you should have all the correct answers. Make sure you send those to me, and I'll give you the points for those, okay? So I'm going to erase this, and let's go to maybe I should go to this first. So if you look on Canvas, under the announcements for today, it says finish the Mass Dissolved Salt Lab. Send me the answers to the 8 questions to get your 10 points, right? We're going to discuss the lab, which we've already done. Then we're going to introduce histograms. So if you go under modules to histograms, Okay, I have the stuff from the book attached right here. I've got the notes attached right here. I think that's what that is. And then some data that you're going to need later on attached right here. Okay? So everything that you need is going to be on those pages. So on the next page in your comp book, let me what this is going to look like if I do that. I think the best way is going to be to do this. Write this in. I need to change the date on there too. So 2.2 is called histograms. You'll read pages 29 through 33. I attached that into Canvas and answer questions 6 through 9. Today's date, I think, is 9/17. And so the objective is pretty simple. The whole goal is we want you to understand how to make a histogram. Okay, it's a way to compare our data. So for the notes, it says a histogram is a plot that presents data by the number of times a value appears in an interval. The interval width is the distance on the histogram from line to line. I'll show you that here in a second. So when plotting a histogram, numbers that fall exactly on a line always add to the right. That's going to be one of our rules. And I've got a couple of different ways to do a histogram. Okay, this first way, and we're talking about, I'm going to give everybody a couple pieces of graph paper here in a second, but we're talking about on a piece of graph paper. So what I did is I just took just some of these squares and wrote them on here. Does that make sense, what I've done? So you're not confused by that? So I've got two different examples. Make sure you draw these examples in there. They'll be helpful later on. This is 0 on an interval, okay, because the 0 is on the vertical line, and an interval width of 1. So from line to line is 1 unit, whatever that unit is. And then the next one is also 1. And then one after that's going to be equal to 1. So it's going to go 0, 1, 2, 3, 4, and so on. Over here, we have 0 between intervals, right? It's not on the line. And then the next middle is 1. So the interval width here is also 1. So from middle to middle is 1. From this middle to the next middle represents 1, and so on. So what I'd like for you to do, I put down at the bottom, says answer questions 6 through 9 after you read through pages 29 through 33. And then you're going to have to make a histogram of the 2.1 all class data. I put that on the histogram page in Canvas. I'll put some tape out here, but you'll need to tape the histogram into 2.1. The data table, don't worry about putting it in there. The way that I want you to do the histogram for 2.1 is I want you to place 0 between intervals, just like this, and use an interval width of 0.1. So instead of using, like they've done here, 0 and 1, this will be 0 and 0.1, 0.2, 0.3, and so on.